All right, let's talk about density. First, density is a physical property. So what does that mean? That means we can observe density without changing the chemical identity of the substance. So we can determine the density of aluminum without changing it into something else. It will still be aluminum. We can observe and measure the density of vegetable oil without changing it into a different substance. Density is an intrinsic property. What does that mean? That means it doesn't depend on the amount of a substance. So if we have a block of wood and we determine the density and we chop the block of wood in half, it still has the same density. Density doesn't depend on amount, it depends on the substance. What else? Density is unique for each substance. So we can use it to identify a substance, kind of like a fingerprint. So how would you do that? Well, for example, you could take an unknown sample of matter, measure the mass on a balance, and then we could measure the volume. One of two ways. If you have something that's a cube, you could just measure one side of the cube, calculate the volume, right? Because the volume is length times width times height, so you would essentially measure one side and then cube that number, because that would be length and width and height. If it is an irregular shape, or you don't want to calculate volume using a ruler, you can use a graduated cylinder. So you would put a known amount of volume in the graduated cylinder, put the item in the graduated cylinder, and then see how much the volume went up after it was added, and that would give you the volume. And then you can calculate the density. If it's an element, those values are going to be on table S. You just tell me what it is. If it's not an element, you would have to be given some options or given more information in order to determine it. You aren't expected to memorize any densities, except for one, but we'll get to that. Okay, so again, for elements, the density is located on table S. So right here, this column. Okay, so you want to know the density of beryllium, right here, 1.85. And it is grams per centimeter cubed. And a centimeter cubed is the same as a milliliter. That's an important thing to remember. Plug it in there. Okay, so remember I said there was one, the density of water. Now at 4 degrees Celsius, the density of water is exactly 1, okay? However, you can see around 4, it is very close to 1. So typically we just say that the density of water, liquid water, is 1, okay? You can see what happens to the density of water as it gets colder, it goes down. And the density of water as it gets warmer, it also goes down. And that's unique for water. That is not what every substance does. Okay, so this explains why ice floats. Because as water, the substance H2O, gets colder, its density actually goes down. Most substances, it's going to go up. So, and that's because of unique bonding called hydrogen bonding. We learn about that later. All right, what else about density? You can calculate it from a mass volume graph. So you can say, oh, the mass was 100, the volume was 100, divide mass divided by volume, and find density. So, all right, so density tells you how compact the mass is. So how tightly those particles are, because remember it's mass divided by volume. So it's how much mass is in the volume. So if we're a solid, we have a high density. So if it's solid aluminum, high density. If we have liquid aluminum, even though it's still aluminum, the density is going to go down some because there's less mass packed in that same volume. And then if we have a gas, the density is going to go down again. Okay, so density is a measure of how tightly packed the particles are. So for the same substance, the density is going to fluctuate depending on the state of matter. All right, density determines floating versus sinking. So an object will float if it is less dense. An object will sink if it is more dense. Okay, so we can construct something very complicated, a density column, and the substances are going to float in layers, and solids are going to be based on density floating or suspended in various liquids. So one quick example, this wood, the density right here, why is it floating? Because its density is less than this. This tar ball is floating right here because it is sinking in the water but floating on the glycerin. Okay? This is the formula for density. It is on table T. You don't memorize it, okay? It's mass over volume. Here's my one suggestion, and we will go over this in class. When you are solving for this, you're going to put density over 1. You're going to plug in the numbers you know, and then cross multiply to solve. Always. Just do it that way. It'll be easier. All right, and then why is the density of a substance different in different states of matter? We talked about it a little bit because density depends on how tightly packed those particles are. So in solids, they're packed more tightly, so the density would be higher. There's density.